What if I told you that SpaceX is learning something from Starship that could completely change the future of space travel? And here's the shocking part. Most people are focused on the launches and explosions, while the real breakthrough is hidden in the data nobody is talking about. Today, we're uncovering the secret science behind Starship and why it could help humanity reach Mars faster than ever before. Hello, everyone. Welcome back to Study Circle EXP 23. Starship is already the most powerful rocket ever built. But what makes it truly revolutionary isn't what you see during launch. Behind every test flight, SpaceX is collecting massive amounts of data about orbital debris, engine performance, atmospheric re-entry, and spacecraft reliability. This information is helping engineers solve problems that have challenged space exploration for decades. In today's video, we'll explore the hidden data Starship is gathering, why scientists are excited about it, and how it could shape the future of missions to the Moon, Mars, and beyond. Make sure you stay until the end, because the final insight might be the most important Starship discovery yet.
Welcome to this explainer. You know, whenever we look at SpaceX's Starship program, it's just so incredibly easy to get distracted by the sheer surface spectacle of it all. I mean, giant rockets, explosions, it's a lot, right? But today, we're going a lot deeper. We're diving into what I like to call Starship's hidden iceberg. Because honestly, the true value of this massive vehicle, it isn't actually the fiery launches you see on the news. It's the quiet, totally invisible data revolution happening way beneath the waterline. And by the end of our time together today, you're gonna see exactly why this hidden data is an absolute game changer for the entire space industry. Let's get into it.
Okay, let's dive into this. So on one hand, we've got the public perception. We're talking the flashy test flights, those impossibly massive rockets, and those wild sci-fi visions of colonizing Mars. But behind all that noise, we have the reality. And the reality is all about quiet telemetry data. While the whole world is glued to their screens watching the fiery spectacle, SpaceX is quietly gathering these invisible performance metrics, stuff that's buried deep in massive engineering reports, but is literally changing our fundamental understanding of orbital mechanics.
Section 1, Tracking Orbital Space Debris. So once Starship actually makes it up to orbit, it takes on this really unexpected role, which naturally brings us to a huge question. Why does this specific orbital data matter so much? I mean, we all know there's a ton of space junk floating around up there, but why is it absolutely critical that a massive vehicle like Starship is the one up there taking notes? We launch satellites literally all the time, right? Well, as you'll see, Starship is an entirely different beast. Look, the sheer amount of junk currently in orbit is basically a ticking time bomb. But Starship isn't just up there trying to dodge it, it's actively mapping it out. Using its super advanced sensors and just its incredible operational flexibility, Starship is gathering real-time data on debris density, how fast those objects are moving, and get this, even their composition. And what's really wild is that it's doing all of this at altitudes where we almost never get this level of granular information. It's essentially taking this totally chaotic, dangerous environment and turning it into mapped, actionable intelligence.
And that brings us to a really powerful reality. As one expert put it, this is the kind of data that scientists have been begging for. Seriously, I literally cannot emphasize enough how monumental this specific data set is. By meticulously tracking every tiny bit of debris it encounters during these test flights and orbital maneuvers, SpaceX is basically handing over the exact information scientists need. We're talking data to ensure satellite safety, radically improve future mission planning, and even lay the very real groundwork for developing actual debris removal tech down the line. It's huge.
Moving on to Section 2, Pushing Raptor Engine Limits.
Now, what's really interesting about this next part is the stark contrast between what we can test on Earth versus what actually happens in flight. Shifting our focus to the ascent phase, it is all about the super granular data streaming back from those massive Raptor engines. See, on the ground, sure, we can test an engine for duration, but it's an incredibly controlled environment. In-flight telemetry, though, that throws the engines into highly variable atmospheric pressures and totally extreme dynamic stress. Ground tests, they simply cannot replicate the thermal management challenges and the massive, massive material stress these engines face when they are physically roaring up through the atmosphere. So, how exactly are they extracting all this incredible data? Well, they do it by executing some incredibly complex, ridiculously high-stakes maneuvers. Step 1 is pushing the throttle range right to its absolute limit, both during ascent and descent. Then, step 2 is the famous Raptor flip maneuver. If you've seen it, you know it places unprecedented, almost unimaginable physical stress on the entire propulsion system. And finally, step 3 is mastering engine reignition in the cold vacuum of space. By deliberately guiding the vehicle through these extreme steps, the telemetry SpaceX gathers allows them to refine engine performance for unmatched reliability and efficiency. And here's the kicker. These insights, they don't just stay with Starship. They directly inform the design of future engines for literally all of SpaceX's ventures.
Section 3. Surviving extreme re-entry heat. So, after the ascent and the orbital coast, we arrive at, without a doubt, the most perilous phase of the entire mission profile, the descent. We're talking about temperatures and pressures that push materials to their absolute breaking point. I mean, Starship's re-entry profile is unlike anything humanity has ever attempted on this kind of massive scale. The sheer forces at play here are staggering. Actually, the data coming back during this specific phase is arguably the single most critical batch of information from the entire flight. Now, to actually survive that absolute breaking point, the Thermal Protection System, or TPS for short, is doing some serious heavy lifting right at the atmospheric interface. But here's what you really have to understand. This isn't just about slapping some heat-resistant tiles on a ship and praying it survives a single one-way trip. Not at all. The data gathered here is specifically aimed at optimizing this vital heat shield barrier for repeated, highly reliable airplane-like reuse. Picture this, as Starship is plummeting back through the atmosphere, literally glowing red hot, it is constantly streaming back a massive, massive volume of data. It's actively monitoring the physical integrity of those thousands of individual tiles, it's measuring real-time heat transfer rates across the entire hull, and then it feeds all of this into advanced models to predict wear and tear with just mind-blowing accuracy. This incredibly granular data, it's exactly what allows engineers to fine-tune their designs. And that's not just for Starship, but honestly for pretty much any future hypersonic vehicle we might want to build.
But before we continue, there's something even more surprising. Most people think the biggest challenge for Starship is simply getting off the ground. But according to the data SpaceX is collecting, the real challenge begins after launch. In fact, one set of measurements revealed details that engineers couldn't fully understand from simulations alone. And what they discovered could influence everything from future moon missions to the first human journey to Mars. So what exactly did Starship reveal? Let's take a closer look.
All right, Section 4, the Flying Space Laboratory. So, the crucial point is, when you combine all of this invisible data, from the violent ascent all the way to that fiery re-entry, it completely forces us to reframe exactly what this vehicle really is. The general public looks up and sees a massive transport rocket built for cargo and astronauts. But the operational reality? The reality is that Starship is actually a flying space laboratory. Seriously, every single time this behemoth leaves the launch pad, it's acting as this giant, highly sensitive scientific probe, scooping up secrets about the absolute extremes of spaceflight.
And the implications of running a flying laboratory of this scale, it is accelerating the entire space industry. Because of the data gathered on orbital debris, we are actively taking steps towards securing our shared space environment. Because of that raw Raptor telemetry, we're unlocking more reliable, far more efficient space travel. And thanks to those brutal, fiery re-entry tests, we are learning how to build reusable spacecraft that can routinely operate in the most extreme conditions imaginable. The sheer pace at which SpaceX is iterating, all based on this astonishingly fast feedback loop of data, is driving innovation. It's plummeting costs, and it's reducing risks faster than arguably ever before in human history.
Which leaves us with one final thought to chew on. We've just explored the hidden iceberg, right? The orbital debris tracking, the extreme engine telemetry, the re-entry survival data, and this whole concept of a flying laboratory. So I have to ask you, what aspect of Starship's development is truly the most revolutionary? Is it the raw, visible power we see on the launch pad? Or is it that quiet, totally invisible data that's fundamentally changing the way we look at the stars? Thank you so much for joining me on this deep dive in today's explainer, and as always, keep your eyes on the data.
So, Starship isn't just a rocket. It's a flying laboratory collecting valuable information every second it flies. From tracking dangerous space debris to improving rocket engines and developing next-generation heat shields, this hidden data is accelerating the future of space exploration. Now I want to hear from you. Which Starship breakthrough excites you the most? The powerful Raptor engines, the reusable heat shield, or the possibility of reaching Mars? Let me know in the comments below. If you enjoyed this video, don't forget to like, subscribe, and turn on notifications so you never miss the latest discoveries from NASA, ISRO, SpaceX, and the world of space science. Thanks for watching Study Circle EXP 23, and I'll see you in the next journey beyond Earth.